Hi everyone, welcome to MyWebUniversity, my YouTube channel. In this session, I'm going to be discussing cybersecurity once again, and we're going to discuss understanding operating system command injection, how you can do OS level command injection, which is commands that you're running on operating system, whether it's Mac, Linux, Windows, any operating system that is Android or anything, it is susceptible to command injection, meaning that it could be the OS have some kind of um, backdoor open in terms of the web server or something that you have some programming running on the web or maybe internally that you allow command injection and how to prevent that one, strategies for prevention. So in this video, I'm going to be discussing that basically and exploring vulnerabilities and methods to protect your system from all kind of vulnerabilities. How do you prevent it? So the first thing is that what is cybersecurity OS injection, command injection, and how to prevent it. That's what this video is all about, okay? And there's a lot of technique that you could be using on a system, whether it's a web server or some software. Malicious code could be injected through your operating system level vulnerabilities or system level operating system level or application or API. And there's a lot of ways of methods that you could strategize your system to take proactive action and how to prevent it. So that's the topic of this video. And this is kind of a little bit higher level on the system level. So I'm going to have a disclaimer. And the following demonstration is for education purpose only. This channel does not promote or encourage any illegal activities. So everything that is I'm going to provide you at this level because it has to do with security and data and how to mitigate these kind of OS injection command lines and how to prevent them. And this channel does not promote any illegal activities or encourage or it's all discouraged. So make sure that you understand that. That's my disclaimer here. Agenda for overview. What are we going to discuss on this session? We're going to talk about introduction to operating system command injection. What is command injection? How do you do that one? So how is command injection attacks works? And then detecting, analyzing of vulnerabilities on your operating system, whether it's Linux, Windows, Mac, or Mac is Unix operating system. So any system is vulnerable to OS command injection and how to prevent them. I'm going to discuss that one, prevention and mitigation strategies. Prevention is a way of being proactive and then system automation and tools that you're writing for your resources, how to mitigate it to just minimize it. If you don't make it zero, at least make sure that you have a backup system just in case if it happens, and then you can prevent it in the future. So all of those steps will be discussed here. And then maintaining ongoing security. Once you prevent these issues that are vulnerable, that is found, it is detected and corrected, and whether you do it OS level patch or operating system or application or database, all kind of prevention could be happening, user level, data level, all of that. Backup systems, snapshots, all of that, steps that you're doing it for the disaster recovery and automation, and how you do a maintenance for ongoing security. Because software could go end of life, software could go need upgrade, firmware needs to be patched, upgraded, or OS level needs to be end of life, you need to upgrade it. A lot of these hardwares and software resources are prone to vulnerabilities. So the older they are, they always are more susceptible to already vulnerability that were detected in the past. And hackers usually They go through what is already known through your systems, knowing you're running an Apache web server or Nginx or a Python or Java or C, C++, whatever programming languages, Perl, Swift, whatever, there's always some sort of Ruby or anything. So there's always some sort of vulnerabilities that is related to it. So we're going to talk about introduction to OS command injection. What is OS level command injection? Basically, every operating system, whether it's Linux, Windows, or Mac, which is Unix, Linux, Unix, or Windows, or Android software, which is also Linux, any software that are running through, whether it's Apple, which is Unix, Doran, BSD, or BSD version, FreeBSD, HPUX. There's a lot of other operating systems that are Unix based also, and there's a lot of different flavor of distribution for Linux, like Fedora distribution, Ubuntu distribution, Red Hat distribution, Rocky distribution. All of these ones are based on Fedora, except Linux, Ubuntu distribution, and Linux Mint, which are Ubuntu distribution, Debian distribution, basically. So I'm going to be talking about what is operating system command injection and what is the definition and overview of command injection. So the nature of command injection allows attackers to run arbitrary system commands on vulnerable hosts without authorization. So you have a host operating system that is running a given operating system, whether it's Linux or Mac or Windows. You are going to just allow some sort of command line injection through system calls, whether that is a system function calls or process open or for Python, or maybe exec for Node.js or exec for C, C++ kind of code. Then it is going to allow you some sort of command injection, and the system could have vulnerabilities if you don't do any kind of filtration on scanning the input, how you can parse those kind of malicious code, how you prevent them. And I have been running a website on the web server. I have been running Linux, Ubuntu in this case, and then I'm going to show you how to prevent it with a number of ways to detect them and correct them, and don't allow those kind of injection. Cause of vulnerabilities: untrusted input passed to the system calls without validating enable command injection attacks. The important thing in this topic that we're talking about is cause of vulnerability is basically you're just making sure that untrusted code does not run without validation. So you validate whether that command is supposed to run on your OS. You're providing a given support service on a given port, and that port has to be, first of all, secure, SSL certificate, HTTPS protocol on port 443, rather than HTTP clear text that is going in a clear text format. So how you mitigate all of that one, and how you install the certificate, how you prevent SSH secure connection with multi-factor authentication or PEV-enabled authentication. We talked about those ones in the past, and I'm going to show you some examples also today. So how do you detect for those ones, and how you correct them? Distinction from the, let me just move this thing out of the way. My Zoom is basically a little bit too big on the text. No matter where I move it, it is just blocking my view. You don't see the Zoom information here. So distinction from other injection attack. So there are two types of attacks here we've talked about. One is the OS injection, which is OS command injection focused. So on the OS level, basically the target execution of operating system commands, and different from fundamental from database or script attacks. There's cross-site scripting attacks. There's database injection that is SQL injection, we call it, that you could do it on the database level, but OS level is all operating system command level. That's the distinction between OS level and SQL injection exploitation. And this topic, I'm not gonna discuss multiple of them at the same time. I'm going to just show you the OS command level. Maybe another video I will show you that SQL injection, which is basically a query to the database, and then you're doing a where clause on the selected statement or update or insert where that condition is true, and you're putting some kind of comments, and then the comment dash dash is basically rejecting, ignoring the rest of your command, whether the password is correct on the where clause or not. You're still injecting that one, so it allows it. But how you prevent it, I'll show you that one also when I discuss on that topic. But I'm going to be discussing OS level already, and then to show you this one on this video. Important of distinction, recognizing the difference, ensure correct security strategies and effective mitigation. By doing that one, basically, you're just not only supporting your operating system, also how to prevent it, to just make sure you don't have vulnerabilities. Common vectors and affected systems. Common attack vectors, web forms, API, and poorly secure interface are primarily entry points for cyber attacks. On a system, sometimes people, they have a password in a flat file. That is another form of it that is poorly secure. So if somebody could get into your system, then they could read those password in a clear text. That is one vulnerability. But through API calls, they could make a call to a flat file if they know the password is written on a default kind of configuration, admin password. They don't even have to read it from your system. They could still just guess it from dark web, and that there's a lot of passwords or already kind of hijacked, and then people, they know how to just do brute force on these kind of default attack also, and then figure out the password. There's a lot of web forms that is kind of easy to just write a comment and then inject a cross-site scripting or SQL injection or OS command line in there, and then somehow embody in the JavaScript or the alert or the rm-rf on the Linux, or remove item on PowerShell. A lot of these tools, they have a lot of commandlets on PowerShell, DOS command prompt, command on DOS and Linux, terminal commands that you could pass on, and then utilities, and a lot of system calls through APIs. You could name it, but there's good news is that you have methods to find these vulnerabilities and correct them, whether it's HTML kind of parsing or some sort of detection on the operating system level or the OS level or application level or programming language. There's a lot of methods to prevent them as well. Vulnerable system with web servers or directly voice command execution are highly susceptible to exploitation. Although this is true, the problem is there, whether it's a web server providing it or API calls or some kind of Python program, some Perl program, some CGI program, some Java code, some networking scripts that you're running it. There's always, these systems are susceptible to exploitation. How you do prevention from penetration testing, how do you do your system, how do you parse these inputs that are making sure that there's no malicious code in between, or there's no OS command level that you're not allowing it. I'll show you all of that one because I have built a system already with teaching the entire Linux online with using your browser. So you can come in and practice Linux online on my web server, and then I'm going to tell you that is secure for the past 45 years. I have it not hacked. And then even if, God forbid, if you are being hacked, you have to have methods of how to restore your system back to normal state without any kind of malicious code running on your system the next time. So you could just prevent it from detecting what happened in the logs and how to mitigate it next time. So some of the vulnerabilities in functions, system calls that are there, this system function is in C and C++ and Python. There's all kind of programming languages, including Jupyter Lab. They are using system and other ones. But usually they either provide it at a different level of command line, like parameters, the argument that you pass on. There's a lot of different type of system, and for exec also. The exec is also for Node.js, for JavaScript stuff you could do, and then you could also do it on C, C++, Python, and there's all kind of exact level of operating system which I could show you. This process open, which is our pipe open, it's kind of like Python functions that I'm doing on my system that you can run multiple operating system commands in a stream. You could do that one. You could do that same thing with a for loop within a system or a process open, and then you can file them together and then pass on with semicolon or something. There's a lot of methods to just hack a site that is not detecting those kind of bash code or system codes or some sort of scripting, and that allows it that they could just have the system that, whether it's buffer overflow vulnerabilities or SQL injection or OS level injection, these API calls could happen at any level within the application, at any programming languages that is allowed. So if the program allows these kind of function calls, make sure that they are securely allowing it. And they sanitize the input, meaning parse the input and make sure that the unsanitize the input, meaning that the input that is coming, it is not on a unsecure commands to be executed, because the commands will be executed if you just allow it on the operating system level, and they could cause problems. Typical attack scenarios and techniques. So on this one, I'm going to be talk about exploitation of user input, how the inputs are coming, attackers or uses vulnerabilities in user input field to inject harmful commands and compromise system. These harmful commands could be any form of syntax that they see that your system is vulnerable for, and they are going to do it through OS level injection or SQL injection or cross-site scripting. And so operating system and application, anything that you provide a service has to be looking for this sort of malicious code. And then there are techniques that they send them in malicious code. There's strategies and technique how to prevent it as well. So malicious codes are chained together to increase the impact of the attacks and bypass defenses. This chain part, sometimes you're running in a cloud or Amazon Web Services, or maybe some sort of virtualization environment, that if they find the malicious code on one server, they might just say, well, it might be 1,000 server that I can just run my malicious code as worm or Trojan horse, and they go silently and then cause the problems. Sometimes they cause the problems by writing the code into the web server's directory or some /temp directory, and then just write it. So there are ways you could mitigate this problem also. And this using meta character, shell meta character. This shell meta characters is also very important on every operating system, like piping or process like greater sign or less than sign or double greater sign. Those ones are redirection, creating the OS command to redirect it to another file, and then later on you execute that file. So you have to look for greater sign, less than sign, double greater sign, ampersand, double ampersand, or statement. Ampersand stand for and. And the double and is also there. The or statement, the not statement within a SQL injection, the insert, all of these ones, insert, update, all of these ones are regular SQL injection that you have to allow it. But sometimes they just do SQL injection with the dash dash, saying that this is whatever comes after this one is a common, ignore it, and all of a sudden, and the rest of the code is not read when the user is equal. Select from table A where username is administrator and password as XYZ, but then before they put the password, they put the kind of code for dash dash, meaning that this is kind of common. So the system or query is going to be run without with ignoring that dash dash. In shell commands, this piping and this meta characters, which is characters about the character, meta characters, or very kind of easy to just create a file, pipe one input of output of one command, the first command to the input of the second command, all of those piping. You do it with semicolon, with ampersand, all of that syntax. I will show you how I could just look at those ones and how to mitigate them so the attacker could not run this shell kind of syntax to run with OS injection on your system. Example of vulnerable codes and exploitation. So some of the examples of it basically is unsafe user input handling. If the user input is not handled properly, direct concatenation user input into system calls can lead to critical vulnerabilities without proper validation. So if the system is calling a system or a Java program, Python program, Perl program, anything, once you just do exec and say exec this, execute this command, or system this command, or popen this command, the command will be executed with the argument. If you don't check for validation of the input to see whether some sort of meta characters were pushed in, or some sort of semicolon or greater sign or something, then your code is going to be easily vulnerable. So make sure that it's secure before you execute these commands like system and exec and popen function calls of the operating system. These are OS level that sometimes like Python and C and Python, again, all of these ones, and this is also C and C++ and Node.js, all of these ones they provided, but these are function within the programming language that allow OS level commands to be executed. Inside the argument that it requires is the command with the parameters of the argument, how you just parse them and making sure that those input from the web that is coming from the web form or from a comment section, they don't have cross-site scripting or SQL injection or OS command level. It's all way of programming it and making sure your developers are also trained so they don't have a flat file saved somewhere that allows the admin log in, all of those things. There's a lot of methods as a software engineering. When you're designing a system, you have to be responsible for making sure your system is secure and test it before you go from testing to integration, from integration to production. Once you're in production, if you didn't detect these things, then millions of people are going to be using it, and before you know it, it's too late. So make sure that you detect all of those ones. And unfortunately, the impact and consequence of successful attack sometimes is really hard. It could be defacing your company. It could have data theft. Successful attacks often result in an unauthorized data access and theft, compromising sensitive information. Data theft could be knowledge also. That is, sometimes they say, well, if China, for example, detect how NASA they explore into going to Mars, and all those schematic, all the data that are there, if that was compromised, obviously that would be very bad for that kind of data theft. They could duplicate the information. Same thing if Russia does it. Same thing with the Department of Defense. If the data are not secure, and that kind of leak could cause a lot of harms to every scenario that you can name it. Then a system compromised. When a system is compromised, it is too late. Attackers can gain control over affected system, leading to false system compromise and misuse. And then once your system is compromised, you don't know if the hacker was, or the attacker was on that minute on your system, or maybe has been there for a week, or they are sitting on your network reading the data and then transferring information from your system. So a system that is compromised is really, really risky. That makes sure that you don't allow this kind of OS level command injection, or SQL injection, or cross-site scripting to be running. All kind of vulnerability is there out there. When you provide services, people are going to run code and Nmap and other services that they could check what port you're running and what ports are open to your system and how vulnerable they are. So service disruption is another thing, is that if your business cannot have service disruption, make sure you have load balance servers, high disaster recovery situation. If earthquake happen, or some kind of flood or fire, how you do make sure that your service is not disrupted. And at the same time, if some kind of malicious code was running on a server A, how you mitigate it to just not go through the network and cause another server or thousands of other servers. So when a distributed denial service attack was happening in Google.com, Google already mitigated by using their H server and the load balance to make sure that they already say that, okay, what are the nodes that are affected, how we could prevent other nodes or other clouds to be kind of compromised. So there's a lot of methods of prevention. And then every time you find out the incident that happened, how to mitigate it for future, that's all your process of your system that needs to be maintained over time, and then updated correctly, and then corrected to the error correction and error detection kind of things. Security vulnerability detection and security vulnerability correction through patching, firmware update, or applying or training users or developers, and then preventing those kind of issues. Unauthorized access, attackers gain unauthorized access or control onto your system, risking security and privacy. So this is another issue that sometimes if they are unauthorized, they shouldn't be on your system no matter what. And then, but if you are having vulnerabilities, you cannot just tell them, no, you're not allowed, because we will prosecute you. The hackers, they just will figure out some way to just not be detected on your system when they do this kind of stuff. Detection and analysis of vulnerabilities, how you detect it, how you analyze it. These vulnerabilities are everywhere, but how do you analyze it and how you detect it? Vulnerability system functions. So as I mentioned, this system function calls, exact function calls, or pipe open function calls, or process open function calls. These are ways. There's a lot of, just for exact, if we do man exact, you will see man exact CLV and so on. All of that one, LV and so on, all of that one will be listed. But then on a given system, these are general 3 of them that I listed here. There's a lot more. And so whenever you're doing it through some, even like operating system command, like allowing some commands, those ones, they could be running outside of the API, because somebody might be internally logged in on your system, a malicious hacker that is running some kind of code, because you have the back door open somehow, and they just knew that backdoor information. Don't do those backdoor open there. At the same time, and when you're just allowing these kind of operating system, disgruntled employee might just be internally doing some kind of malicious code to just get unauthorized access to some of the parts that they are not supposed to be doing it. And then the prevention, you can detect the vulnerabilities and reject unsafe commands and utilities through pipelines, redirection, command redirection like double greater sign or greater sign or less than sign or semicolon, or even like pipeline, the or statement, the end statement, and so on. Many other related security risks. There's a lot of ways I could show you on examples that should be programmatically detected. Programmatically meaning that you're not sitting in front of a computer 24/7. So your system is vulnerable when you're sleeping. So if it is detecting through cron jobs, automation, and the program itself parse the unsafe code, and then it's whether static code that is your source code or a dynamic code that is running on the web that is pulling some data, making sure that that unsafe data is not allowed to run on your system. That is your security measurement. And security risks that should all be programmatically detected and corrected. Back up all your system. Back up all your system. You might have snapshot of your system, backup monthly, full backup, and weekly, and then keep a daily snapshot, hourly snapshot, and then make sure your systems are kind of backed up regularly, at the same time replicated on multiple locations. If you're on the cloud, make sure that you have a East Zone and West Zone, like Amazon Web Services. So if something happened in New York, East Zone, then you already are back up and running on your West Zone, Amazon Web Services. Or in case of fire, if something happens, you could shut down one area of your system and then run it on another area of network that is not having any fire issues. So back up your system and make sure that the backup of your system contains all the important operating system, application, database. So whatever is vulnerable or you risk it and that you lost some data, you restore those ones right away, application. And all these software is often as your business needs. So if your business needs to be restoring the backup and restore the system without any downtime, make sure your disaster recovery plans for that one. And make sure you test your backup system and plan for disaster recovery. So if the disaster happened, you have to recover. And it's not like a earthquake happened and then now you have no recovery to restore your data and application and all the work that you did in number of years of that one just because a earthquake happened when your servers are not load balanced and they are not running on two different locations or multiple different distributed centers, whether it's data centers or multiple location on web services, on cloud, Google Cloud, Amazon Cloud. Make sure your disaster recovery is in a way to minimize your system downtime. Sometimes you minimize it, reduce it, it's kind of transparent to the user. The disaster happened, maybe a hard disk crash or maybe a server went down, but because you're on a virtualized servers that the hypervisor already restored it on another VM, or maybe it is an Amazon Web Services that out of 1,000 server, 2 of the Google server went down, and 998 other ones were load balanced to just respond to all the queries. So it's transparent to the user. The user didn't even know that 2 servers were down. And then make sure that those 2 servers are not staying down. As soon as you find out from the logs or from monitors or from activity, make sure you restore them back to the 1,000 that was on your design level system. And then the tools and methods for vulnerability discovery. What are the tools that you look for it. Basically, sometimes static code, which is your source code. Static code, you have to scan static code to detect vulnerabilities without execution program. So maybe a Python program might have the P open or system call, or a C or C++, the exact, or Node.js, the exact. Whenever you are detecting those kind of source code, that it is susceptible for vulnerabilities because they don't check for validating the input, then make sure that you tell the developers that they need to mitigate that one and find out the solution. Penetration testing. Penetration testing simulates attack to identify security weakness like voice command injection. So your AI kind of software that you write to look for these signs of penetration testing, and how you prevent it when you detect it, then you have to correct it. Dynamic scanning tools. Sometimes your security software, you're running it dynamically to scan all the operating system, application, database, everything to make sure and those applications are not susceptible or vulnerable there. Dynamic scanning tools detect vulnerabilities by analyzing running application in real time. That's very, very important. Indicators of potential OS command flaws. So unfiltered user input, any user input that is not filtered out for those meta characters like greater sign, less than sign, all of those ones, they're very dangerous. System commands to be executed through user input that is vulnerability that could cause harms to your system. Unusual system behavior. So sometimes on your logs, you might see some unusual activity that 1 million requests coming from a subnet or an IP address, or hundreds of them are coming. Or sometimes you could see malicious code on the program that was sent, but then your system through prevention, it detected and wrote the logs what was coming. So your system logs for reports of errors, and then access logs, and what IP addresses, what browser was used, and what was the session, query string, all of that one is on your system logs that you can look for them. And then sometimes you could even find out how your system was being attacked, and then whether it was attacked successfully or you prevented. The system logs could help you further detect it. And then the unusual system behavior, sometimes you could see the system responds very slowly because maybe there's malicious code running on your system to slow your network down, or pulling data while it's doing some kind of functions that you allow it, and then it runs function A as well as function Z, and that's not supposed to be running function Z. Revealing error messages. Sometimes on the error message, you could see a lot of details, information through the signals and all the ways that it happens. Case studies of real world incident. Learning from document attacks, basic documented attacks. Examining past attacks reveals common vulnerabilities and mistakes to avoid insecurity practices. Sometimes you can learn from other people's mistake, from other web servers vulnerability that was exploited. And then a lot of the things that on the internet you could detect it and say, oh, this port HTTP was open when they're supposed to be running on HTTPS secure port. So, or this flat file was open, or SQL injection allows without parsing any kind of input from the data, or OS command level was detected. You could learn from other people's mistake and then make sure that you have a solution for it. Important of proactive measures. Proactive means that you have to be taking measurements in advance to just decide what if this happened? What if this happened? What if this happened? So you're kind of like doing a lot of what if logical scenarios, and then you say that if A happens, then I just have a solution for that. If B happens, then I have a solution for that. So you're just doing proactively before it happens. You proactively secure strategies can prevent or reduce the impact of future attacks significantly. These proactive could happen through automation, through monitoring your systems, through interactive activities that you could be watching your system at the same time. You take some proactive before it happens, or sometimes AI kind of software, you write it to mitigate these kind of issues before they happen. Before a port is open, you make sure that that port is secure. Prevention and mitigation strategies. So on this one, I'm going to show you a very good demonstration with examples. And I'm going to use MyWebUniversity.com, which is my website. It is a secure page. HTTPS stand for Hypertext Transfer Protocol Secure, meaning that SSL's secure socket layer is running. The certificate and the data that is going between the client and MyWebUniversity.com is all going in encryption form, so I'm secure. And for OS level command injection, even though I allow this OS command level injection, a lot of the companies, even like Google's and other companies, they don't allow OS command level injection for security purpose. But because I'm teaching for student purpose, for developers, and I'm not doing anything with kind of money, there's no money involved. So I'm allowing it, this kind of a little bit too brave to be allowing OS command injection on your system, and that is could be compromised. But because I have securely prevented the solution with all the knowledge that I have gained from my Bachelor of Science and Master of Science from computer science and past 36 years or 35 years of operating system and system analyst, system administration, programming languages, software engineering, consulting, database level, all kind of work that I have done. I know these levels in and out for Windows, for Linux, and for Unix. So I know how to prevent them, and I'm going to show you these demos today. So stay tuned, don't go anywhere. Watch this video to the end of it, and you're going to learn a lot of it. And if you have to build a website from this one, these videos, I could be very helpful for you to just do something like that yourself. Best practices for securing codes. Avoid direct voice command. So they say never execute operating system commands directly from user input to prevent secure vulnerabilities. However, I did it, and I'm going to show you how to prevent it. So, and this is very risky. Nobody on the developer level or OS level, people that they are training security, usually they say don't allow OS command level. It's not safe. Yes, it's not safe, but if you check for the direct input and make sure all the inputs are parsed, then it is very safe. And I have been doing it for 25 years. And it's not been exploited. So I'm going to tell you that yes, while there's these issues are happening, there's also solution for it. That's the good news, that you can prevent it. For example, if you say, well, HTTP is a clear text, the solution is HTTPS. With secure socket layer encryption. And then you say SSH is, or telnet is open connection with clear text. Telnet is there, but secure SSH is going through LDAP, secure SSH, secure shell SSH, or SCOPY or secure FTP. And so secure file transfer protocol or secure copy, SCOPY, all of those ones are going through port 22. But then if you're going through just authentication with LDAP or password, that is not secure. So then you have to do a multi-factor authentication or PEV-enabled or two-factor authentication to allow other means of authentication. Authentication meaning that you have a username and password, but with multi-factor authentication on top of username and password, what you know is what you have. What you have is maybe on the two-factor authentication is or say token, or maybe it's a PEV-enabled smart card, personal identification verification of a smart card that you allow it with multi-factor authentication. So a lot of methods to prevent it. Similarly, with the OS level injection, you have solution to do prevention for it by not allowing meta characters and other ones to be running. And there's a lot of methods to prevent it. Parameterized calls. So the function calls, the API calls that are coming there, implement parameterized calls to separate code and data, reducing the risk of injection attack. So the command, you might just do system calls. Now you have to say, okay, this command pwd, print working directory, even though I don't want to allow it, but maybe because I'm providing a web server for people to learn, I want to just say present working directory means this. So I want them to see the output of it on the web. And then at the same time, they might just say, well, now they know that information. By knowing that information, they may just get another way to get into your system running multiple. Now you have to prevent this kind of combined syntax of saying, okay, they know that PWD, they want to redirect a file into your web server root directory, then how you prevent those read and write access. All of that information, you have to make sure you mitigate it. Follow secure guidelines. I just talked about a few of examples. Adhere to establish secure coding guidance to maintain code safety and integrity. This is not just you, this is all your developers, all the software that you install, all the operating system that is get patched, making sure that they adhere to the established secure coding. And so this is for everybody. And then we're going to talk about input validation sanitization technique. So that there's a lot of ways to say, well, I'm going to restrict a lot of inputs for different reasons. A strict input validation, enforce rigorous checks on user input and prevent harmful or malformed data from entering the system. So if any code that is malicious or malformed, making sure that you prevent them for entering your system. The sanitization technique, cleanse input by removing or coding harmful characters to protect against injection attack. Sometimes you don't have to remove the encoding harmful attacks. You just don't allow it to be executed in the first place, because you might be just checking for needle in the haystack. A hacker that is very, very smart, that is a very kind of like expert, they may find out, maybe they wrote the whole OSSH, maybe they wrote the OpenSSL. So they know these backdoors themselves. If they wrote the entire operating system and someday they just want to write another code to just show you that how good they are, they may just find out a way to do it. But if you just look for those kind of meta characters and other ones, don't allow it. And just tell them that this is not allowed to run, and that's it. You don't have to waste your time to just look for needle in the haystack. Use of security framework and system hardening. The system hardening based on the operating system, the application that you install, the software that are there. There are a lot of ways you can do. For example, if you do OpenBSD versus FreeBSD, or maybe versus Red Hat versus Unix, the bare bone of OpenBSD might allow you to run some kind of a Jambox server to just have the minimum OS level and don't run all these other packages that are not safe, or compilers or interpreters and other ones that are coming with a developer version of Red Hat or Linux, Ubuntu or something out of the door, and you just get Python or code, a malicious code that could be written, and then the end of life on the operating system or version may allow certain vulnerabilities. So make sure that the system is hardening to say the minimum that you need to install and allow those kind of minimum ports open and everything, the safer your system will be. Security frameworks. Security frameworks offer structures, approaches to safely abstract system functions and protect against threats. There are different security frameworks like NIST, National Institute of Standard Technology, or FISMA. So you have to use their standard and make sure your systems are kind of meeting that requirement. System hardening. System hardening involves restricting permission, isolating critical component, and to reduce vulnerabilities. On top of packages and software installation and configuration, you have to also make sure that users are kind of having the proper permissions, and then whether they're users of regular users, or maybe power user, or maybe root level administrative access, all of those ones you have to do it correctly. Maintaining ongoing security. So once you did your system, the maintaining ongoing security, being proactive, you have to be proactive. Monitor all your resources, whether it's hardware, software, data, and user activities. Look at the logs, system logs. Maybe you could look at all these software that you're running on your system. Through logs of them, you could check. There's a lot of application for it that support these kind of security software that you could check on it. Keep your system up to date. Apply firmware. Apply critical patch updates. CPU stand not for central processing unit. In this case, is Oracle critical patch update is CPU, or OS level critical patch update is there. And then there are sometimes patches that you have to do as OS level, sometimes database, sometimes software, sometimes WebLogic, sometimes Node.js, sometimes Java, sometimes Python. Any of those Firefox, any software that are needed to be updated, make sure your systems are up to date. If the operating system is not updated regularly, make sure that if they're vulnerable, they upgrade them. And then a Python version needs to be updated or upgraded, or pip install or pip upgrade, all of that one, Node.js, anything that you're running on your system, make sure you do them correctly with the proper update and upgrades. Backup and keep snapshot of your data and software in case of disaster and recovery. So if the disaster happened, make sure that you have a good backup system. And I could show you my backup is really good. So if something happened on my server, even though I'm just doing this server for education purpose to help developers and students around the world, and then I just still have a backup in case if someday in the past 25 years, nobody has hacked my system. Maybe it is safe. Maybe there's still some sort of vulnerability somewhere there that a hacker might know, that if they want to detect it, and then find out that issue, and then they hack it, I have a backup, I can restore it, and then I have no problem doing it. Sometimes people, they do ransomware on your system, that they could kind of encrypt your files, and then they ask for money, and then they just say, okay, if you gave me this much money, I could unencrypt it for you. But if you have your backup system, you could just restore from your backup system. You don't have to give any ransom. And then next time you have to make sure that you have measurement to detect that one before it happen again. Plan for disaster recovery and how to reduce, minimize downtime. I should have talked about transparency last time, because the more servers you have, the more load balance, the edge server and other ones, the more your system is kind of safer, then disaster recovery is going to be easier. But if you have one system standalone and you don't have a redundancy, and if the hard disk crash, now you have a problem. And then you have to wait for the vendor to just change the hard disk or buy another hard disk to restore your data. That's also downtime. So make sure you minimize all those kind of downtime and to zero. Write AI and other automated tools for ongoing security of all resources. So sometimes you write automation tools with a program. Sometimes you could have a cloud computing. Sometimes you could have infrastructure that is maybe on the cloud, or maybe Amazon Web Services, or maybe Google stuff on the cloud. Anything that you do, sometimes you might just write artificial intelligence code to automate your proactive activities in finding out the ongoing security issues that was there. This AI stuff is ongoing. It's kind of detecting as it happens dynamically, and it is correcting and patching it and everything, or at least monitoring the system and reporting to you what's going on. Regularly security assessment and updates. The security assessment has to be done regularly. Vulnerable scanning through finding what ports are open, what vulnerabilities are on the OS level, what application level, or programming languages, packages, users, anything that is on your system, data, how they are vulnerable. You constantly scan them through your security software to scan them. And sometimes you could create open SPL tickets, open security program log. SPL ticket, SPL stands for security problem log. Most company, they just have software to create a ticket saying that this port is not running on secure port, that is HTTP, or maybe SSH is vulnerable with this kind of malicious code vulnerabilities, patch it. Or maybe Firefox have a new version, patch it. All these kind of scanning software could inform you ahead of time, and that's why proactive. And patch management. So for the operating system, you might be running RPMs, or maybe Yum, or DNF, or Red Hat, or Fedora, or Rocky distribution, and maybe apt and apt-get and Snap on Ubuntu, and then Windows WinGit and on Windows. All of these software, they have a lot of ways to patch your vulnerabilities. And how do you detect it with Oracle? Like, for example, Critical Patch App, they provide you those ones with WebLogic, with all of these other software, Apache web servers, how you patch it, Tomcat, everything that you're running on your web server, Node.js, or maybe Nginx, anything, you do it. But developers training and awareness. Developers mostly should be aware of all these vulnerabilities. When the vulnerabilities are coming, it's not just the system administrator or DBA or a network administrator responsibility. All the system developers, or also application developers, system developers, and any other developers that are coding, make sure that they don't introduce new vulnerabilities to your system. And so anybody that is in development, they should be all trained to make sure they adhere to all the responsibility of coding safe. Awareness of emerging threats. Keeping developers informed on new security threats, reduce risk in application development. Sometimes developers are being informed through the web. Sometimes they check for a vulnerability because it was done through API calls for the scanning software, and it detected. Sometimes word of mouth, everybody could talk about it and they could help each other. And reducing injection flaws is going to be everybody's responsibility. Educate developers are less likely to introduce injection flaws during software creation. Same thing with sysadmin, or same thing with DBA, same thing with network administrator, same thing with end user, same thing with anybody that is having sudo access or root access to a given system. Make sure that they are aware of all the flaws of a given system. So importance of planning, incident response planning. When an incident happened, how you detect it and how you do some kind of guidance so you could avoid it in the future. Importance of planning. A clear incident response plan enables organization to act quickly and minimize damage during attacks. So if your response plan is already clear, written somewhere that is available to all the developers, all the administrators, all the operation teams, they can look at it on a daily basis and make sure when the incident happened, how they can be proactive and how they can measure it and correct it at the very minimum time. Containment and recovery. Effective incident response focuses on containing threats and recovering system promptly to reduce downtime. As a conclusion, threat awareness. So threat awareness, understanding of operating system and congestion risk is essential for effective mitigation and system protection. Secure code practices. We talked about secure code, making sure static code data in transition and data at rest. Secure code, static code data is at rest. Whatever source code you have is already at rest. Make sure they are safe. Data in transition, when you're going to a web server or doing HTTPS, the data packets could go to the network, data in transition. Those are make sure it is safe. When you're doing a secure copy, file transfer between the systems, all of these transferring between two systems or two different applications, they are making sure that they are securely going in a safe, secure page. Continuous vigilance, ongoing monitors and updating of your systems are critical to defend against emerging threats. So this is dynamically happening, and that's the ongoing security part of it. So when you're saying your system is AI software is basically ongoing, detecting and correcting vulnerabilities and scanning ports that are open, scanning vulnerabilities on your system, that is how you are going to write your procedure for better planning of it and how you could mitigate when disaster happen, how you minimize the downtime. All of that one is based on your proactive situation. So now we are done with this part of the video. We're not done with the actual demo. And remember the part that I mentioned about providing you the web server here somewhere. Let me just see which one was it. I said that I'm going to show you right here. So this one was saying demonstrate with examples. I'm going to go to MyWebUniversity, which is my website, show you SQL and OS command level injection and how you securely prevent them. To do that one, I just already went to build another website. So if I go on my website here, I could see that mywebuniversity.com is the website. And notice that it's HTTPS, meaning that it's secure page. And these two keys, the private key and public key, is SSL secure socket layer. That is meaning that every where I click on, all that information is passed on between my client, my browser here, and my MyWebUniversity website itself, or going through a secure page, encrypted form. So it is safe to just have this one, and nothing is going in a clear text. Same thing if you're going to google.com, if you just see like, for example, google.com, you can see HTTPS here. Same thing with youtube.com. All of these web servers, youtube.com, you can see it is secure. And if you click on the secure, it says connection and data, and then basically if I just click on it, you could see connection is secure. And when you click on it, it just says, okay, you want to look at the certificate, it's google.com, because Google owns YouTube also. So, and then the certificate, how good it is, when is it there. Similarly, for my web university, if we look at the connection is secure, this lock is meaning that it's secure. So I could say certificate is valid, and you could see all the information. The common name is www.mywebuniversity.com, and the expiration date is on Saturday, May 9 of 2026. By that time, I already renew it again. The fingerprints, all of that one is saying that this SHA kind of certificate of hash code, SHA-256. Fingerprint is basically encrypting all that data with a strength of 256 bits of SHA algorithm. And then the details, you also have the MyWebUniversity certificate and all the other information. So without further ado, I'm going to show you the number of things that I built for these services. So I provide you like a YouTube channel, which is my Web University YouTube channel in English. And then if you look at this one, under the popular videos, there's a lot of videos on Linux, Red Hat from zero to hero. People are watching it, and Rocky Linux, PDF, Solaris operating system, Linux. So there's thousands of videos that are in the related topics, whether they're like 1.7K videos that are, whether they're computer science courses that I taught at Pasadena City College at some point, Python or C, C++, Bash scripting, or sometimes I just made videos that are just to help the student out. Sometimes I wrote PDF files on the website, so you could come in and say, well, show me all the documentation that we have. For each of these books that you come in, you could learn a lot of documentation. For example, if you're interested to learn the Red Hat Enterprise Linux 9, there's 12,000 PDF files here. So if you're looking for Python, you say, okay, Python here, I'm going to say Python 3.9 PDF, and I just generate you the PDF files. Normally, if you're on a Linux server, if you just say man Python, then this is going to tell you the Python interpreter in a text format. But I made it so easy for you that you could just come in here on my web server on your browser, and you search for Python, and you get the entire things in PDF format. I wrote a Python program to generate all these thousands of more than 40,000 PDF files for Python, for Red Hat, for Rocky, for Ubuntu, for PowerShell, for Windows, all of that one available on my website. And this is not just it, it's more than 100,000 altogether, but it's not it. So if I type in HTTPS, now I could say, okay, do you want to go to HTTPS www.python.org? You click on this one, I take you to a python.org website. Then you go on their documentation, and then you could see all of that related topics that are there. Everything is there, right? So at the same time, I told you that if you're on a Linux machine, sorry, screen. Let me do a quit here, clear screen. Let's say man system. You could see the system exec in a shell command. So this is a system function calls within C and C++, and this is the construct is a string of commands that is just basically a pointer to a command. With the command, you're just spinning off exec L. Remember the exec stuff? So the system is doing this exec call, and this exec call is running a Bourne shell with the -C for command, and the actual command passed on. And if there's argument to it, you could do this one. So these are all function calls within the system. So if I say man exec, you could see that just for exec, you have execCL, execLP, execLE, execCV. All of these functions, and each one of them are explained with their parameters and argument that they were passed on. Whichever one you want to use, and then that's how they are there. Same thing with Python. For example, if I say which Python, here I could say Python version. And then I could say, for example, go to Python here, and then here I could just say import OS level here. Now I say dir of OS. So everything that module OS provides, all of these functions are there. So now I could say, well, clear this is screen here. I'm inside the Python interpreter. So if I do a directory, this is what's available. But if I say os.system, and then I just use the OS level command, clear command, now I just did the clear command. If I just say, what is my system cat minus n etc os dash release, then I could say that I'm on Ubuntu 24.02 long-term support. If I just say, show me my Python version, Python that version, it shows me that one. But at the same time, if I say import sys, and then sys.version info, that also gave me the Python version 3. Because I'm using the module this. So inside this module, these other functions or attributes that are available, properties that are there, like system version, version, I have to type in version correctly, and then that would tell you. So os.system, notice that the clear command, it clears it. I have to close it, and that argument takes a command here. So if I say uname -a, it will tell me that one. If I say give me the print working directory, or show me the pep list, what are the modules that are on the system, and then inside this one I could say, let me just do clear again. So this one inside here, if I just do pipe a list, and then I'm interested on grep -i, remember this piping that I was telling you, the meta character? Inside this os.system call, I'm using this pipe symbol here, and I'm saying that show me request module. So only the request module, and then it says there. If I just say, show me request and I'm using the egrep, which means extended grep, global regular expression. And now I could say the or statement here, say it's either request or it is NumPy. So those two module, I want to be showing it. So NumPy, it did not show that one. For some reason, the or statement was broken pipe. So somehow it did not allow it. Let me just do this. This is the problem. Here I say this or that. And now it's going to do that one. Okay. Because how you parse it, that is the kind of interpretation of your system. But so far, I have not introduced you to the web form of it. I'm just showing you os.system. So if I say, now let's create an array of running multiple commands. So if I just create a list, say commands, and then as equal, and then I put pwd, and then host name, and then also let's say calendar. So that's good enough, and then maybe date too. Those are the commands that I want to execute. So I could say type of commands, this is a list, right? So if I say commands, it's those commands. If I say for CMD and commands, and then say os.system, notice that I'm going to just run those commands without any checking, saying that run the command here, and then they are going to run. But notice that return is 0, 0 here, but the output is correct for PWD and other ones. So if I just say, now I did that one, os.system, let's do a clear command. And instead of the system, I'm going to use the process open. So if I say help os.p open, I want to show you the syntax of this function called p open help os. Let me just see this. Yeah. So OS is there, and then the p open is most likely somewhere there. And then I could say without this, and then that will show me in the actual p open command and argument and all that. So I don't need the syntax because I memorized all of these ones. os.system, I'm going to clear the screen. So I showed you my commands contain that list of commands. So now I say for CMD and commands, and then just say print the f string. I'm going to just say what is my command, and say my command is, and then I'm just going to say CMD, and then that's going to be passed on to the f string as whatever the command is, whether it's pwd, hostname, or cal, or this. And then after that one, I could say another print and actually do that one, but this is just to display that command. Now I'm going to say stream is equal cmd.p open, process open, p open, and then I'm going to run the CMD. Then instead of this one, I actually need OS dot this, because I open import OS already. So I'm going to do that one, and then I say now output is equal stream dot read function. So I read the socket that I open as a process open, and then now I'm going to say print the actual command. So this one is output. So that the output is there. I'm going to say f string. I could do single quote also if I want to say the output is, but since I use the output is, so let's do this. And then the output is, and then I'm going to have to close the output here and then put the single quote again. So now if I run this command, basically it should run this for loop. It gets the command for each of these list pwd, hostname, cal, date commands in this list commands, and run it. Say the command is pwd, the command is hostname, the command is calendar, date, and then open this pipe open that we showed you at the presentation of the thing. So p open, os.p open will open the command, then it read it as a stream. This time we will not get the 0 output because it just is much cleaner. So you see that my command is pwd, the output is this. And then my command is hostname, the output is that. And my command is the calendar, the output is this. My command is date, and the output is that. So it clearly wrote that one, and we use the popen function calls. So I showed you those ones from Python, but Python is not the only one that I could show you. I could show you on C, C++, and other ones. However, let me show you the website, how to prevent these ones. So the fact that I'm providing all these things online for you, I have to make sure that the commands are not being executed. So if I just have this chapter 3, for example, say intermediate Linux command, and I provide these commands, a list of them command level, and change mode requires some sort of security, then I write you documentation to use it like this. So you can read it and then the example by example like a book. So I did that one. And if you go to chapter, for example, df command, which it does not require any kind of level, then now I give you what is df command is and how to run the command. df-h is human readable. So when you click on it, it will give you a human readable format output here. This was your command. It ran on my cloud, and then I give you the output on the browser for you. So you could do all of these other ones also, and you could get the output here. This is for my regular one that I have done it. For this video, I'm going to show you also chapter 4 of the book. So chapter 4 of the book is more advanced levels, and it is about 88 commands. Some of them like user add, user del, user mode. If you click on it, I give you documentation. But if you just want to run a command that is not required, like process stream 3, it's going to show you a system 3 of process. Like this one is for system D, system 1 process. You could see that this PS3.1, it gives you all these function calls. So you can also do these ones with other commands. Like if I want to say run pwd, you could just do a query string here, and you get the output here, CGI bin. If you say run the date command, I give you the date command. Run the cat plus dash n dash etc release host, you are able to run these ones. But notice I'm doing it on the query string, passing on to the command line to the Python program. So somebody might just say, well, can I just do rm minus rf in here? And you might try it to say rm plus dash rf plus wahid.star. Let's say you're doing it, it says, oh, you wrote this one, wahid.star, I'm not allowing it. You say, well, I'm not going to restrict it to only wahid. I'm going to just say, remove everything on the root partition. And then I say, no, you're not allowed to do that one. So this is what I mean by command parsing, that you're going to detect on those ones and correct it. And when you open a program like this, notice that I did it on multiple server locations. So if I go here on the main page and I go to chapter 5, shell scripting, and I say, can I just run commands on this one? Yes, you can run these commands here, and then just say, for example, if I say, show me the calendar, it's going to give you the calendar. And then you say calendar, and then semicolon, rm minus rf root. And then I say, no, you're not allowed to do that one. You're running the calendar, but you're putting this equal sign, semicolon sign to do some kind of malicious code after. So you could say, well, can I write to your web server? So if I just know my web server is pwd as user Ben, I could say, okay, just write echo rm minus rf slash into the web server greater sign slash user slash lib slash cgi dash Ben slash loop, and then the name of the file is called t.sh, and then semicolon, and then I say bash minus x, that the file name is slash user slash lib slash cgi slash bin slash loop slash t.sh. Now the person tried all that one, it wasted this time. I detected this was parsed into the command, and how smart is that code is, right? So it detected, says this command is not allowed. You passed on this one. I found out this was malicious, and I'm not allowing anything to do this one. So there's a lot of ways to prevent it. In order for you to learn more, I actually did this one on this other interface that I just did it Saturday, I believe. So let me just go to close this other one and show you one without any banner or any advertisement. So if I go here and then I go say, okay, chapter 15, Learn Linux Online, this interface still has the banner stuff, right? This is chapter 15. So then I just wrote another program to say, don't show me these ads because I want to just demo and then I want them to clearly understand what I'm doing it. So the program is under no ads directory, and it is the same kind of information here. So notice there's no ad on this one. And then now if I just say, can you give me a PWD? Yes, it is print working directory. Can you do ls minus l? Yes. These are command injections. So they say don't allow it, but if you allow it, something that you want to just allow it, something you don't want to allow. So ls minus l does not allow, but the calendar, it does allow it. And then PWD is allowed there, right? So then I could say, well, since they allow me on this one, I'm gonna just write a code here, say echo rm minus rf, and I'm gonna delete this file linux star.cgi. On this one, say star.cgi on the directory, but I'm gonna just write this information to this path, which is slash user. This time, let's try it. I could write it to slash user slash left slash CGI dash bin, and then no ads. And then we say t.sh, for example, t.bash, whatever you name it. And then put a semicolon, say bash minus x, and then the same script name, which is user left CGI dash bin slash no ads slash t.sh. If you try that one, I said, no, you're not allowed to do that one. See that this was your command and that command is not allowed. So all of a sudden I say, well, not everybody's a hacker. I don't assume that whatever they were doing it, maybe that person wrote something saying that PWD or ls minus l. So I said the combination of the or statement that you're doing here, I'm not going to allow, because you might be just saying PWD or rm minus rf and slash. This one is not allowed. You see this? I'm not allowing that one. Or PWD and rm minus rf slash. So anything that you're doing it with some these meta characters, I have to detect it. So I could say detect for those ones. And at the same time, I say maybe the person is trying to learn Linux and they're practicing it. Maybe I could give him further documentation on Linux Ubuntu to help him out. So you come in on this URL that I provide you. I say, come in on my website. And then this was actually HTML. So I messed up and dash L copy. When I copied this one, I did not copy everything. So this is now copied everything with HTML, and then now it's there. So if you're looking for change mode, then you have change mode 2, which is a system level manual pages, right? So this is really neat. And if you just are looking for something like ZSH, notice the ZSH, there's 2 of 15. So one of the ZSH.1 PDF file, this is the documentation here. At the same time, if you say this is not enough because it's only 9 pages, I want to learn the entire Linux website. You see this HTTPS, you could search Control F HTTPS and then look for zsh.website.org website, and then go to the public. You could download all those ones or just go here and then look for documentation here. So the English version, United States America, you could search it and then you could see all the documentation here. If you want the PDF version of it, obviously, you just search for PDF version of it. And then right here is the documentation, manual, and then other ones there. So if you're looking for this, you could see HTML version as well as PDF version. And then whichever one you are interested, if you're looking at HTML version, you click in here and you see all of that one line by one line. And then if you're looking for PDF version, European version, or United States letter, this is ZSH. So a lot of documentation on my website, a lot of resources. At the same time, when I'm saying that SQL injection, you're preventing for OS levels injection, this is what I mean. So my system is allowing these commands, but at the same time, it's safe to not allow any OS level commands with system or exec or function that I don't want to do, allow it. So if I say, show me a calendar minus J of this format, and says this is not allowed, but maybe calendar dash J 9070. Certain ones, if I just allow it and these commands, it is going to do it. Like calendar 9070, it is going to do it. So why is it not allowing anything? Calendar. Maybe the calendar command is not in my list of allowed. And so calendar is, okay, calendar is not allowed. That is not good because I allow it on my other side. So let me just see what happened here. The direct path, so if I just go here and say, this is the one that I'm allowing it, and then I want to see calendar here. Yeah, calendar is allowed. Calendar 19070, it is allowed. No, calendar 19070 is not allowed. Okay, I understand why it's not happening. Calendar minus J to see if it's Julian format. So if I go on the command line, I say calendar minus J, it is going to allow it. Calendar minus J 19070. So there's tools that I have to prevent these things and there. Now I'm going to just go on my site here. So the program that I have here is that I'm allowing certain things and certain things I'm not allowing it. So in this program, I'm going to just look at it quickly and allow you a few commands that I'm not allowing it. So let's just pause for a second. I'm going to update it and allow those commands on the operating system to show you if something is not allowed and you want to allow it, how you do it. So I'm going to pause. Okay, I fixed the issue that was not allowing the command with minus J option. Now you can type in calendar here, it will run, and then say calendar 19070. It will show that one for the January epoch calendar or the Unix epoch calendar, or calendar minus J 19070, that also is allowed. And then calendar minus calendar, anything that you want to just write. The calendar itself is a command calendar 29098. If the command is allowed, I'm going to allow that one. So right, and then the options are there. And then cat, for example, minus n apc os dash release, that is going to show you the os dash release, or cat minus e atc os dash release. Each one of them that they required for the option that I have to do is, let me just make sure that atc os dash release. Yeah, if I do the os dash release, cat minus n is provided, but then let's see, cat minus e etc password file, and then I just say you're not allowed to read the password file. But then you could also do cat minus n etc shadow file, that is not going to allow you there. As you can see, you're not supposed to allow those kind of files. At the same time, if they want to see man password, I should be able to allow those kind of commands to get manual pages on the operating system. So if they say man PWD, then I should give him the PWD with manual pages. Similarly, like if they do man lsof, list of open files, and it is going to give you the manual pages. But if they say lsof minus I, and then say go port 443, then it's going to just say you're not allowed. Or you type in who, it's not allowed. Who am I? It's not allowed. So certain things you cannot allow it, like you name ID-UN is not supposed to be allowed. So cat minus n etc or host name, host file, if I allow that one, I allow it. If I don't allow it, it's just going to just say, this is just arbitrary command that you did it, I just ignored it. I did not run anything there. So you could also do commands that are valid on the system that I'm allowing. And df-h is allowed, and then I'm going to give you output of that one. ls minus l, if you just want a long listing of the files there, it is allowed. So if I say touch, let's say, file one.txt, I could say target, I'm not going to be allowing that one. So they cannot do it. User add, say, XYZ. And so somebody tried to create a user XYZ or user add user one, then I'm not allowing it, and that they do that. Group add, it's not allowed. JavaScript. So, for example, you could say a script source is equal, and you could say alert, and then some sort of function call, say, let me just say alert, and then say within this, say, maybe I could say compromised. And then we say, okay, if we just scare the person that your system is compromised with that one, and within the JavaScript, we say run this code as injection, because they allow it. It says, no, you're not allowed to run that command. No output is given for this command. So if you just say, okay, I'm going to say a script command and say anything that one. rm minus rf greater sign test .sh there, and just do that one. I'm not allowing anything. Delete. Okay, so if I run the command, say, I did who there, and then let's see, there's other ways of running and hacking the system. So if I say run a Python program, Perl, or a Python -c, and then say inside here the command, say import OS, and then after that one say os.system, and then say inside there rm minus rf slash, and then that one we want to execute that one. If you just do that one, you wasted your time and says this command is not allowed. So a lot of ways you could just prevent these systems, and I'm going to end this video here. If you haven't subscribed to our channel, if I earned your credit, please go ahead, subscribe. Make sure that you watch all these videos and a lot of the technical documentation on PDF formats that I have here for you. You're learning a lot from it. And so if you go on the website also, there's thousands of PDF file documentation. Like, for example, let's say you go on chapter 4, and then you see the documentation I have here, and technical documentation. There's thousands of PDF files here for you, whether it's Red Hat, Linux, Rocky, or Windows and PowerShell. So for PowerShell command, there's 7,000 files, and you could just get here, Control F, get dash process, and then you just do that. And then obviously for like something like if you're looking for Node.js stuff here, if you search, say, okay, go ahead to the dynamic documentation here, and just generate me Node.js kind of documents. I create you on the fly this Node PDF file, and then you say, okay, great, this is all good, but it is only 10 pages. Yeah, do a Control F and then search for HTTPS, and then go to nodejs.org website here. Now you're on their documentation, and then on the docs, you could get all kind of OS level commands function here. So if you're inside Linux, Ubuntu here, say, let me just say here, I'm going to exit out of myself, and then I say, which node, you can see node is there. Now I say os.cpus, and then I could call it as a function, get all the OS stuff. os.user info, get all the information. os.type, it is that one. So if I do os dot and then tab this one, all the functions that are available for me, it is there. Whether I get the os dot uptime to get the system uptime, I could get that one, and then that's a string, and then you can convert it. os dot platform. So all of that details are there, right? And then os dot version. See what version of operating system we run in Ubuntu. And then you can also get this one from exit out of this one and say .exit, and then say cat minus n etc os dash release. Here you could get that information, or just say uname dash a will just tell you that. And then so id dash un get n password, and then ID wlitfi or Wahid, my username, and then could do it. Who is there? ID, screen, df dash it. All these commands are there. Cat minus b 5 show me the calendar for the current month, which is July, and 5 months before that one. So if I want to see 2 months before that one, I just say 2, or 2 months after, I just say after. These kind of syntax are there. So man calendar would give you all the calendar information. And then sometimes like man lsof is there. So if I just say sudo su dash, I become root here, and then I just type in my password for my user, so I can have the root password now. Switch user do. This is stand for switch user do, not super user do. Some people, they assume that it's super user. No, you're basically switching user to another user. So in order to have it, sometimes you switch user as a regular user. So you could do switch user dash Wahid. That doesn't mean that I'm using super user Wahid. I'm just switching user to Wahid. I was already root as that one. So SU stand for switch user, not super user. And then sudo stand for switch user, which means switch user and do this command at the same time. So if I just don't do this one, I say run the sudo and then run a command that requires a user to be added. For example, I say user add XYZ. I just tried to do that when it says no, you're not allowed, permission denied. So I could say now sudo in front of it says switch user and do this command. Now the user was added. So now I say password XYZ, because I'm still not allowed there. I could do another sudo in front of it and then type in the password. So if I just type in a weak password, I will have a weak password, but it's not going to allow me. I have to have a better password. So that is going to just be there, but I'm going to say user del XYZ. I don't want to just have that user. And then since it is not a sudo, I could say sudo there, and then now the XYZ is gone. But under /home, if the account was created to XYZ, I have to delete it. Okay, so Let me just show you one more thing about the privilege stuff here that I did it on this, and then you can do it also on PowerShell on Windows. So if I go here and say cd to this directory, clear screen, and then run the command where it says node, here you could see that the os.user info. This one is basically telling me the user information on my C drive user there. User.platform, that is different than Linux, right? So not for user os.user platform. And then os.type is there. And then os.version is that information there. So os.cpus, and then you can see all of those informations are given there. So if I exit out here and say which Python inside here, which is not there. So I'm going to say Python dash dash version or Python dash V, it is there. So now I go to Python here, and this time I say os.system, and if I just run the command import first os and then os.system, I'm going to run the command say hostname, give me the host name, it's gonna tell me. And I say run the directory command, it's gonna run the directory command. Run the clear screen command, clear screen in there. So if I want to run a PowerShell command, let's say I say get dash process, because that one is a PowerShell, I need to just say in front of it, say I am outside PowerShell running os.system, but in order to execute that get dash process, I have to pass it on within PowerShell. But however, if I want to do something like clear screen command, which is the clear command is here, and then I could say CLS, that one will clear the screen. Notice if I do a clear here, this is saying that it's not allowed, but I say, no, go ahead, run PowerShell in front of it, and it clear my screen, it will do that one. And get dash command will show all the commands there. So all of the list of the things that you could do on a given OS, it depends on what you're planning to do there, right? That is your OS level execution. Let me show you one more thing on here. So on this one, I was going to show you sudo sudash, and now I'm there. I go ps3 1, and that is process stream 1. But at the same time, I showed you like if I go netstat minus an, and then grep minus I for all port for listen, what are the ports that I'm listening? There's a lot of them. So if I say grep 22, that is a SSH right there. And then I say grep minus I 22 from etc services, then it's showing that SSH is running. But if I see running for SSH, then it's going to say that. So now if I say, show me a secure port, egrep for SSH or SFTP, secure FTP, or scopy. Those ones, they all show that they're running and they're listening. So only 22 is open, secure FTP, and other ones are listening to this one through UDP and there, right? So there's these ones. So if I say clear screen lsof minus I, I'm going to be listening to port 443, which is my Apache web server through HTTPS. I could also say systemctl status Apache 2. That is basically the process ID of Apache. You can see here is 1712. So I could also say lsof minus p 1712. That is also going to show me all the ports that are listening through HTTPS that is connected to Apache web server, where the logs are written and everything. I could detect it. lsof minus I colon 22 will just show me the secure port on this one. And then do SSH 443 is there. I could run nmap and other stuff, but I don't want to run those stuff because of security reasons, and I just don't want to look for anything that I could compromise my system. But at the same time, like I told you that backup, I have a lot of automation on the system, like cron tab -L. You can see all my backup system, new backup system, monthly backup system, incremental backup system, everything that I could just run the backup system. So if I go to home, Wahid, new programs, shells, and then let's see if I do cron tab -L, grep -I backup. So you can see that under the script that I have is for these ones under shells var dub and monthly backup. So under this one var dub directory react, and then now I have this monthly backup, which is monthly backup $. So if I look at that script here, I could say, show me the content of that one. So I could show you how I do my backup. It's all there. It's automated and it's just my copyright, all the information is there. At the same time, what directories and everything that I'm backing up. So if I just want to back up my system as of today, I can run that one. And then all I have to do is say, okay, that is there. And then let's do a laugh out loud cat -N, and -N is fine. So you can see that the backup system, you can see it in different colors every time they do. There's a lot of ways you can look at it and enjoy it, but let's just do run the backup, cron tab -L. Notice that I'm doing this backup on first day of the month, and then 15 days of the month, and then at a certain time passed on 8 p.m. Midnight, so on the 25th and so on. All of that one, there's reason that I'm doing it. So if I just say cron tab -L, and I want to run this one, for example, monthly backup, and just to show you this one. So I could just say, copy everything here from this and just run it again. So I just did that one. I'm going to just go to Tmax, clear screen, and then, sorry, clear screen. And then I do PWD here. I said, I'm gonna go to Tmax and then just go by default here and then say, okay, I'm on Tmax. If I just say Control B and then detach, the prefix is detached. Now I say Tmax ls, I am on the 2 session. So I could just close one of them because I had the previous one. Let me just become root again. And I say Tmax ls, and I'm going to say Tmax attach dash target 0. So I'm going to connect to this target 0. I'm going to exit out of this one, Tmax ls. Now I only have target 1. So I say Tmax attach. Now I'm on the target. Control B, detach, and then I just say Tmax ls. I just have that one. If I just say Tmax attach and I say run the top command, now I go here, clear screen, top command, and then I say Control B detach. Watch here, if I just exit out of this one and become root back, even if I just close it, I can close it and come back, sudo su dash, and now I'm there, id dash un. I say Tmax ls, and then I say, let me attach to it again, Tmax attach. Now I'm running the top still. So if I quit out of the top here, I could open multiple pane, but I will just do this one, the backup. Cron tab -L showed me my backup here. I could just say, okay, run this monthly backup here, and then just run that one. Now this program is going to run on the system, and just writes the output to this logs here. right? So if I just say that's good, and then I could do Control B detach, and then now I say PS minus EF grep minus I tar, it is all the tar backups are happening right here. All of that one is there at the same time. And then the cron tap minus L, and the backup is written right here. And the data that is on the logs that I'm capturing, it is written here. You can see all the activity that is keep happening in there. If I do a tail minus F on it, I could see exactly what's happening on that one. So Control C out of it, tail minus F, and then paste that one. I could see every time whatever is happening on it, I could see it. I could have also not redirected to the output there. I could have done it on the screen. But you could Control C out of it, say Tmax ls, and then I have that one. I could attach to it, and I could see the output when it's completed. At the same time, I have a directory under home Wahid new backup, I believe. Yeah. So right here, the backups are happening in there. So my systems are being backed up. And if I do ls minus ltr, clear screen ls minus ltr, I'm sorry, ls minus ltr. So you can see that as of 7/28 today, all of these systems are happening there. So if I say, show me tail of minus 15 of them, the last 15 of them, then you can see that July 28 is today, and then they're happening right here in the full backup. And if I do the same command, notice these timestamp of these files are changing because the backup is still going. You can see it was 408 and now it's 264. This full backup is happening there. Every time you run, you get a different timestamp and size of them differently, and everything is being changed. The timestamp is almost the same in this one, but eventually when it's written, all of them, the time changes, it will change that one. So the size of the file is growing. And if I do a df-h on it, I could say, first I have to parse it to $awk print $9. That would give me the file name, and then say xargs disk usage minus sh. And then it tells you the size of each one of them there. So there's a lot of neat stuff. And then if I just wanted in color, laugh out loud cat, I could get it in color. Remember that PS3 that I was telling you one? You could get that one, process stream 3 minus P, the thread minus P, the processes. You can get all that information. And if you just like it in color, laugh out loud cat, and you can get it in animation. It will just do it one line at a time in a very colorful method. So with that in mind, I'm going to end this video. I hope you learned a lot from it, and I hope you enjoyed. God bless you all, and make sure that you subscribe and share the knowledge with your friends, co-workers, and neighbors, and loved ones, whichever one you want to just share with. You're gonna inspire them with their life, and they're gonna be happy from you and saying that you changed their life for better. Because this is college level courses that you're learning online, and you're going to be happy. Okay, I'm gonna exit out of this one, exit out of this. Now I have exit out here. This one is Python, so I'm gonna exit out of here, close this one, and then these other ones are, this is my Web University website that I have the English version and the Farsi channel also. The Farsi channel is for Afghan community. I was originally born in Kabul, Afghanistan. When I finished high school, I left the country, and I got my degrees in New York, basically, and started studying computer science in New York 3 years, and then I transferred to Cal State Fullerton in California, State University Fullerton, and I graduated with my bachelor and master. And the past 30 years, I've been doing working full-time here. So I'm making these videos to change your life for better. God bless you all. Take care and enjoy it. Oh, for soccer stuff, I just do that one to make sure that if I used to coach soccer. So if you're watching these ones, they're not for any other reasons, but try to inspire you to, if I could do things like that, maybe you could do even better. With my age and other things, I'm just trying to make changes on younger generation so they can just be inspired and then keep going, never quit in their life. And life is tough on all of us, but we have to keep going. Take care. God bless you. Bye bye.